On 11 feet on center. And so what you'll do is like you put diamond angle this way, this one angle that way. So you have to think of like a 3D cylinder. So it needs like a kind of a 20-foot radius by itself for every volt to ground as much energy. But most people just need to work.
So this is the machine that's installing the tubes for geothermal. This is the geothermal tubing rolled out to the ground. So, main support pillar. Connection stylings. Here. So this is the precast elevator shaft, and apparently this made all the difference in the assembly structure and time frames welded in. Let's come out for a full view. Sorry about the shakiness, everybody. This is what we're looking at. Okay, and let's go inside. So, this is the particularly interesting part, which we can brighten up a little bit. So, entryway, precast elevator shaft. Okay. Let's move up that. This is a main pile, and they've actually cantilevered it off that main pile, which made the cost changes non-existent because of the steel beam and the cantilever. Here is a precast shaft, number 2. There we go. And you can see it goes all the way up. Calm that down a little bit. It's really pretty in here. And all that supported off that pillar. This pillar, both sides, cantilevered. This whole room is not under footing right here. Somehow they can do this.
Well, most engineers think you go the lightest material makes it cheaper, but I'm like, no. If I have 10 columns at 1/4 inch or 5 columns at 1/2 inch, the material difference is 0. It's the erection time. The erectors putting 10 columns or 5 columns. It's faster. 5 columns, obviously, right? Because erectors work on piece counts more than they do weight. That crane can handle anywhere from 500 pounds to 50,000 pounds. So it doesn't matter how heavy that column is? No, because for him to erect the column, zero difference.
Do you think material cost is less expensive than that?
Oh yeah.
Engaged in labor cost.
Well, there's been reports out there for years, like steel, the actual material cost of the steel in the package, like total package, is 10% of the value of the job.
Compared
So-
to having long levels of concrete, which
And from the steel business I learned many years ago, there's a balance point. Too light and you have too many members, it's too expensive. Too heavy, everything is just too big and it's just too pricey.
So you want to distribute the piles as far apart as you possibly can.
I do everything to reduce
More oil
piles.
per pile.
Yeah. I'll put a slightly bigger beam in and I'll put a slightly bigger column in if it saves me another column. Because think of it, on any column connection, it's not just the column, it's the connections on every level as well.
The lack of connections allows
You know, it's not just the cost perspective. Because I was saying to Don is when I look at on the main floor, the expanse of the space and what you gain out of the design and the possibilities of space, it's unbelievable.
Yeah, literally, you have a blank canvas on these buildings and you can do anything
so is this all
with.
your Sherbrooke stuff that's coming into play here?
Yeah, this is Serge and I. This is all of our engineering. This is the two of us putting it together, and it is a team effort. Like it's not. That's why like I have to teach because I need somebody to replace me, which that's like
No, I just wanted to ask you how much the architect plays a role in this. Is
not
it
a lot.
structural engineering?
No, it's all structural. He tells us, like he gives me the design. I lay out the columns, and they can move a few things if necessary, and away we go. I try to conform to his design as much as
Right, so
possible.
McKinley Burkhardt needs to see this because this might be difficult to see before because other structural engineering may not have been done like this.
Exactly. Exactly. Usually they go bigger and heavier, and they don't understand how to mitigate and minimize and to reduce the costs. Most guys, they'll come in and be like, and they're used to the typical design elements, which what we do is not typical. I just ignore what everyone else has been taught in the past and say, no, there's a better way to space columns, there's a better way to do other things. And that's the big difference is that I don't have some guy telling me, you can't do columns like this, it'll never work. It's like, no, it does, because these hollow core here, these are 32 feet long, right? So between columns is 32 feet. Well, the drive lane's 25 feet. How many guys in the business can have a clear drive lane with like 6 transfer beams in this corner to let the cars go around? And I was like, well, we can't because of transfer beams. I'm like, no, you can. It's just change your material, and I have no transfer. I'll show you the only transfer beams. The easy way to tell a transfer beam, see the shear down here in the beam? This makes it a transfer beam. There's a column above it. So whenever you see that, it has a column on it. So this right here is my second heaviest beam in the whole building. That's the only transfer beam. And that's so that I can put 2 cars right here. Because if this had come down, it's right in the middle of the parking lot. So I get 2 cars here because of this transfer beam. But it's the only one.
That makes sense.
So what about the structural engineering do we have to be able to communicate visually to the architects?
Well, this is the beautiful part is I don't care. In 150 feet, you get a 60 feet is what you need for parking on the light pole.
So the rail comes down here.
Literally standing right. Yeah, that's the greatest truck is in the middle of the driveway. I still don't have gas on it. And how many other guys can say, I put the entire Castle Place arcade up and went to without turning the gas on? Yeah. And that gas is not very much. On control, it's not. It's not much. Here we are doing a Castle Place arcade.
Look at this light beam, it's fucking gorgeous.
Yes.
So this is the precast stairwell Don's entering into right now. Let's go in. Wow, it's so gorgeous. Look at that. I gotta take a picture. Picture that. The beauty of construction sites. And then you can see here precast seams and the connector points.
Where'd you use?
Everything's underneath. We either pull holes through it or you run underneath.
So what, you have a false seam?
Everything's dropped. So that's 8 feet. So we'll have a 9-foot ceiling here. But when you put the 9 foot up, we still have a like 8-foot-inch ceiling cavity for everything to run.
Versus the width of that?
Yeah, about the bottom of that beam is the ceiling height.
So you run everything inside of that?
Most of that is like 6 foot up. You go 6 inches deep. It's actually not that big in one direction.
Okay, so here's the hollow core 4-foot slabs running the length of, like, that's got to be one of the biggest slabs I've ever seen, actually. So then this is poured over to make a level floor. See here. Framing. And we're going to go up that stairwell. This is
To use this.
common area.
Common areas, so there'll be a bike room, some storage, there'll be a big roof deck.
Is this safe, right? Yeah, I can walk on it. I just want to make sure I wasn't.
Put these down. Just stay 4 feet from the edges.
Yeah, I just want to take a shot of this.
I mean, you'll slide in your boots, but
For sure, that's why I brought them. Okay, so this is cool. This is really cool. Look at this here. Okay. All right. We're gonna... Let's go back to 24 millimeter. A little bit here. Let's open it up. There. To there. Kind of see all the stuff you're looking for. Right there. And this is off the precast elevator shaft that I was showing you earlier.
how do you do a fire-rated wall with no roof on before you can? It's impossible. He could literally come today and hang his meter banks on here, rough in all of his stuff and be done. Yeah, I can get moisture on, it's not going to hurt it for now. But how else do you get ahead and rough in the full electrical on a fire-rated wall without having a precast wall? It's impossible.
It's interesting when you see the intensity of the beams, right?
This is because we're storing 6 inches of water on the roof.
When you look at them, you see them, and you go, how can this be cheaper than wood?
No kidding, right?
But you think that.
Nope. because I've done the math. The moment you lose a warehouse bid as a steel guy for $8 a square
As long
foot,
as you lose a what?
my first bid I lost on a warehouse, supply and install steel,
Yeah.
for a 100,000 square foot warehouse, 35 feet tall. So that's metal deck, all the steel, like all the 1,000 square feet. The winning bid was 675. My bid was 825. I'm like, how the fuck do you build 100,000 square feet for 675? And yet some guy in the wood frame business would tell you it's $15 a square foot for the same thing. But he can't go 30 foot tall, 30 foot column spacing.
The 30-foot spacing is really noticeable.
And so when I was in the steel business, that's what really triggered it for me, which is what pushed me down this path. Was I'm like,
It's not quite good.
well, it's like this. It's a 100,000 square foot warehouse,
Yeah.
and the supply and the install of the steel package and the metal deck was, we'll call it $8 a square foot. It was $800,000.
Yes.
Well, a wood package, which would max give you 10 foot tall, would be $15 a square foot, or 1.5 million as an equivalent, but you'd be 10 foot tall, columns every 12 feet. So how is wood not cheaper than steel? I've reversed the question on myself. So then when I started doing the math backwards, this column is an example, okay? It's 6 by 6 by 5/8, goes right to the bottom. Total weight of the whole column from top to bottom is probably, we'll say 4,500 pounds. It could be off a little bit. The cost of steel material, on average, is 60 cents a pound. So that column is $2,200 fabricated. Installed, it's probably worth $5,000. Well, $5,000 of material for wood, you could never build a column that tall, that strong, at $5,000 of wood. And the labor to install it, you'd have 4 guys working at $25 an hour, trying to frame it to get there. And so when one iron worker or 4 iron workers can lay this building, which is 83,000 square feet, in 3 months, that means I'm spending on average $60,000 a month in labor. When a framer might have 20 guys and could do it in the same time frame, but his labor rate would be $180,000 equivalent. But that's just labor, right? When we did the material price, like Niche 1 in Calgary, we priced out the material both
So
ways.
is it the labor that's killing the wood?
Both. Both in Calgary, Niche 1, you saw the building. The wood package supply only was worth more than the steel package supply and install.
Just the wood package.
And that was from the main floor up. The steel package included the parquet. So when we totaled it up, it was essentially $950,000 for what you saw today, final cost, versus an estimate of $1.5 million equivalent in the wood package. And that was on 30,000 square feet.
Hey, where are you?
30,000 square feet. Here's something we haven't seen yet. This is some kind of super cool.
That was the benefit. Now it's like we build A to Z at once. We can press the schedule. So what we took was originally a big flat line. A, B, yeah, so what we said is do it all at once. But with my partners, now we're trying to call you got a great life, right? Try. Whether it's shingles, whether it's flat roof, it doesn't matter.
What do you bring on top?
A flat roof, just torch down 2-ply SPS on 6-inch slope
That was
insulation.
can you do this one?
Oh yeah, all day. Yeah, as long as it's not like they can't do the top sheet until it's like -10. And he has to do it in smaller sections, but it doesnesn't matter. In winter, it's easier. What's easier to shovel, water or snow?
So how long before you're all closed down?
Mid-February.
Is that your question?
So mid-February, then you start the interiors.
And then we're 3 months. And the reality is, my schedule is here, is here. So we do what we can, but
Is that drywall?
oh yeah, it's all exterior board. We have curtain wall. We have curtain wall. Like everything except this balcony here. My wall is fucking waterproof. But if you do it with this frame, it's not all we do is pump the top.
Top floor. Okay, so you're going to want to see how we butt up against this, for sure. Widen it out a bit. Okay. Bring it down to this. here. And then the free path on 15. Goes right there. Free path on 16. And then this would be the finished window wall. So let's take a look at some hollow core beauty. On beam, stacked on, framed out. Just to give some context, that's the parkade down there. And if I zoom it out, let's see, this is right along the boundary line. They kept inside the parameters of the property the entire build. You see, goes along here, and they never reached or broke the property line, which I thought was pretty neat. Efficiency.
That was a list of questions. It's about, take the pictures, like come in here and get a shot, like take one away, but then get this in here and get the picture in here so they can see the rebar to the hollow core and the pins. Because they're like, well, what do you do? We just shoot the pins down, right?
Yeah.
And some of those things, that's the important stuff.
Okay. Oh, I have the cap on. Why is it so dark all of a sudden? I put the lens cap on. Okay, so this is the balcony, the patio outside. So you can see how it connects up to the hollow core. And then, let's just open this up a bit. The rebar comes right out through the middle. Got it? This is how it's connected. Nice and simple. Patio step. Okay, on the outside, patio. Right here looks like an interesting connection point. See if we can't focus on that a little farther. It's coming down. A little overexposed, but it's super dark in here. Let's see if we can open that up a bit more. There we go. Boom, boom, boom. Okay. And again, there's that rebar coming up in between. I don't know if that's important, but it looks kind of significant. Right there. Let's see how that fits consistently between each hollow core slab. Here's the precast elevator shaft, but this is a stairwell, and you can see how it's put together up here. You bring it down to the support column. You'll see the rebar coming in right out of there. Just open that up a bit. So that's the rebar that goes between each precast section. And then we've got welding here on that block. It's up. And you can see the assembly of the precast units. Oh, it's so precise. It's crazy. Here, see how it together. From this perspective, we're going to have to bring this down here. Okay, top to bottom on this angle. Especially into that beam system right there. And you can see how this beam just connects and supports it. And then we come onto the outside of it, an idea. And here's this corner distribution. Okay, there's those little babies. Come around this way. Connecting point. Open that down a bit. So there. Whole connection. Open that up again. Just custom lip. The lip's really interesting. I would have never thought that there's a lip there. This way. This way. Same thing. All the way to here, and this is going to be 365 rotation of that similar shaft. Open it up a bit. Let's see. This would be really interesting for premium homes. Instead of using the MGO board, you could just simply go with the precast aesthetic finish, and it's way smoother. And so there, that goes up to the elevator. Okay, so both doors opening, the beam.
Well, and these are air shafts here. So this is actually a good picture. Air shafts. So this is the return air.
Return air for the elevator?
No, for the whole building.
For the whole building, I mean.
This is all the return air, and it goes all the way up to the roof. This one has a piece of plywood on it because this is the supply air, and this goes straight down the parquet as well because it feeds the lobby, and it feeds all the floors with supply air all the way up.
Supply air all the way up.
And then this is where the elevator shaft is with the beams. The divider beams are done on every floor for the elevator guys so that they're all set up so that they can actually have They just put the rails for that now.
Yeah, it's way safer for them too. Way
It's all
safer.
done. Everything's done ahead of time. Nobody has to go in the shaft and drywall it. Nobody has to go in the shaft and mud it and paint it and do any of that stuff. That shaft is now 100% done.
That's just to give you like a general overview. I'm sure this is familiar to everybody, but I didn't want to neglect it after look at that flare. I didn't want to neglect that after coming all the way to Edmonton for 2 hours. And then let's just go zoom in on this a little bit. There's the precast elevator shaft and stairwells.